Alright, today we're going to start the baffling installation on the Lycoming engine. And we have it off the mount here, which is a unique way to do it and really helpful. So we'll show you how we did it on the RV4. So the first thing we're going to do is take out the oil dipstick, especially when it comes to fitting the right rear baffle, and we want to be very careful to cover that hole with some good tape that we know is not going to come loose, because if you drop a screw in there, it is definitely going to ruin your day. We'll start with the valve covers, and here it's not going to fit perfectly, so just hold it in place, make some little marks of where it's a little bit tight to the cover plate. And then we'll take that back to the workbench and use a file and sandpaper and Dremel tool as required to get it to fit. It may require some back and forth filing and fitting, especially if you have the orange silicone gaskets on your valve covers. They tend to stick out a little bit more than the cork ones, even though they are definitely better for sealing. So it may require a little bit more fitment back and forth. So we'll do that 4 times for the 4 cylinders in our case. We'll screw them in place, and even after you screw them in place, it might require a little bit of trimming later once it gets it in the proper location. Again, you can see the orange silicone gasket, which causes a little bit of the interference. So I might have to go back and mark it again, just to make sure that it's sitting flush. So if you look from the top of the engine down, you shouldn't see any gap there. So now we've done all 4 sides. Now we're not really following the plans or the directions. We are going to potentially plenum this engine. I think that is going to be the way we're going to go. So I'm not really following the plans here, so it might vary for you. Just notice that the front baffling and the rear baffling do not connect because there is some movement required in the engine. So these are not going to get riveted together and secured. Okay, now we'll start with the baffling behind cylinder number 3, because it is going to require some modifications for cooling. Now, if you look down through the cylinder number 3 here, you can see at that point here, you can't really see any light down through the cylinder because the cylinder butts up against the baffling. If we compare that to cylinder number 4, you'll see all the air, see the light coming through all the cylinder fins. So you get nice cooling on cylinder number 4 because they are obviously installed 180 out. Now, the other issue that you run into is that that is the manifold pressure pickup there, so you might have to trim the back of the baffling to clear that, so we'll do that at the same time. So what we're going to do is create a gap between cylinder number 3 to improve the cooling. And we can do that by laying a plate and having some angle. This is how I've done it before. Again, just curving the surface there using this seamer tool. But there's actually a little bit of easier way to do it. So using this tool to get the angles and then transferring that to a piece of aluminum. And I used 32 thou 2024 aluminum. Now here's the problem that we're talking about. So you can see how the cylinder doesn't really have any cooling fins on the back of it. And that's not the case for cylinder number 4, because obviously the cylinders are installed 180 out. The cylinders are identical on either side of the engine. So you will have that problem actually on the front of cylinder number 2. So you may see some modifications to the baffling on the front of cylinder number 2 as well, but I don't do that on my engine since it seems to cool decently. So like I said, you could come up with some angle plan, but here's probably the easiest way to do it. I just measured those angles, drew it onto some 32 thou aluminum, and we'll take that to a brake and bend it before we end up cutting it. So there's what it looks like after we do the 90-degree bends and we trim it all up, and that's just going to sit in there and create a small gap. It doesn't have to be very big. So now we're going to definitely improve the cooling behind cylinder number 3. We drill and cleco it in place, and we do require flush rivets on the bottom because that is up against the cylinder. The top you can use whatever you want. And there, once we've cut the baffling away, you can see how we're creating that gap area to improve the cooling behind that cylinder number 3. And there's what it looks like from the top. I did put a couple little tabs on there to increase the strength of it, and then once it's all riveted in place and this ends up getting powder coated, we will go in there with some high temp RTV and seal it all off. So there it is, all riveted in place. and that is going to increase the cooling of cylinder number 3 significantly under your Lycoming engine, at least for this baffling setup you have here. And you'll see that modification on certified airplanes as well. It's a well-documented thing. Now, the other problem that we ran into is when we put the right rear baffle on, it didn't quite sit flush against the cylinder. There was a little bit of gap in there, which is going to be quite a bit of spillage. And there is a flange on the side of that baffling that you see clecoed into there. So what we'll do is actually cut that flange off. You can see when I push on the aluminum, there's too much gap between the actual baffling and the cylinder. So we'll actually cut that flange off of the side piece, and we'll put some 63 thou angle aluminum in there. So there's the actual flange cut off. We'll set the 63 thou aluminum in place, and we're just going to drill a few holes in the bottom because, like I said, potentially, well, most probably we'll be making a plenum for this engine instead of using the normal sealing gaskets. And that might that might actually pull down the baffling closer to the cylinder. So we don't want to drill too high because we may end up just cutting it off. That makes sense. So that solves that problem. Now we go back to the rear left, and you'll see that it's actually made out of 6061 aluminum, which is is a lot softer than 2024. And that's because the mount and oil cooler back there, which has a lot of vibration, tendency to crack. But we'll talk more about that later. But for this piece here, the left side kind of in the middle, it ends up hitting one of the nuts on the cylinder, so we'll have to actually cut out that red area there to relieve that. So there we've gone ahead and removed that area, and this is the offending nut on the cylinder that you'll have to clear. And there's an AN4 bolt that's going to go through this part as well that we'll have to create a spacer for. So there we have the back left portion on. Again, it's just clamped. There's only a couple clecos in the bottom because we are going to plenum this later, so we don't want to drill it too high because we'll probably end up cutting it off anyways. There will be some trimming and filing on the back part. You can see how the contour of this back part doesn't really match the engine. So again, it's just bolting that stuff in place or holding it in place and then clearing the area that's required. So here's the AN4 bolt. You'll have to create that spacer there, and it might vary a little bit length on your installation. And I just create those by put them in the drill press and pushing them down onto sandpaper is kind of the easy way to do it. Now we'll need to trim on the top back part of the engine as well. It seems to interfere a little bit. And then we'll put this center brace in, which gets a couple bolts through the crankcase. And then we're just going to drill one hole again, low down on this one. We're not going to drill a top one because we'll probably end up cutting this piece down if we end up planning the engine. Here are the reinforcement plates that go on the sides, and they will have flush rivets. They don't all require flush rivets, but we might as well make them all the same so we don't really have to guess, because they are going to sit up against the cylinder, so most of them will be flush rivets. And there, everything is riveted in place, and again, you might have to go through the contour of the actual rocker cover and make sure that those clear as well. So now we move on to the front left. And this has a couple mounting screws on the bottom. There's the first one in the back, and actually out of the kit, it lines up really nicely, so we just basically clean it up. And then there's a second front one that they're going to have to fabricate. So that gets made out of some 63 thou aluminum and as well as an angle. And bolting it in place, and you will have to grind out on the aluminum like you see there to clear the actual screw head itself. And I use flush rivets on the top because we are going to plenum this later, so potentially there could be some fiberglass in this area. And I screw the baffles together. So that's one thing I do on the left side and the right side. You can see it here as well. Getting the baffling on and off when it's all riveted together is actually quite challenging. It might seem easy in the installation process, but it will be in practical process. It'll be harder because the prop potentially will be in the way. So there's all the baffling in. That's all we're going to stop for now. We'll do a lot more work later. Obviously, this is just part one. Build yourself something, take it for a rip. We'll see you on the next one. Cheers.